Hello everyone, I'm Dr. Q. Welcome to my channel. In today's class, we'll discuss the quantitative economic analysis and elasticities. In last video, we discussed the quality change on demand function. For example, if price of product increase, how will that change quantity demanded? We say normally decrease because of lower demand. So they have inverse relationship. And whenever income increase, if it were normal goods, the demand will increase as well. So we know the direction of change, but we didn't do change by how much. So for example, if price increased by 1%, how will that change the quantity demanded by how many percentage? Quantity demanded will decrease by 2%, 1%, or 10%. So in this video, we'll use elasticity as a quantitative tool to forecast changes in revenue, price, or units of sold. And we'll illustrate very important test called total revenue test, explain the relationship between elasticity, price, and total revenue. And we'll discuss the three factors that determine the demand of elasticity. So whenever one of those factors change, the elasticity of demand change. And we'll explain the relationship between marginal revenue and the own price elasticity of demand. We'll further talk about how to calculate elasticity from linear demand function and a log linear demand function. So a quick review. I assume you have watched my video about elasticity. Here's a quick review about elasticity's concept. Elasticity is a measurement of a responsiveness of one variable change to the change in another variable. If variable X change and Y change in response to the X change very dramatically, then we say Y is responsive to the X change and it is elastic. There's elastic relationship. And how to measure in particular, we use percentage change. We say price increased by 1%. How does that influence the quantity demand is decreased by how many percentage? As opposed to absolute value. Because of that, it is free of a measurement of unit. Elasticity is a number as opposed to there's measurement of unit like meters or miles or later or dollars. So we can compare vastly different products. We can compare the elasticity of demand of toilet paper against the house, against furniture, against computer. So we can compare very different products. But if we were talking about absolute value change in price, the $1 increase on the price of toilet paper or a shaker of salt is the percentage change is very different from $1 increase in a house or a vehicle. The percentage is very different. Okay? So we use percentage change as opposed to absolute value, monetary value change. So the elasticity formula is the following. If we pick two variables, any two variables, if they're related, G and S, and we want to check how does G change in response to the change of S, then we write as elasticity G in response to the change of S. The numerator is percentage change. Delta means change in G. The denominator is the cause, percentage change in S. So causal effect, effect on numerator change because of change of denominator S. And in math, whenever the functional relationship exists, G can be expressed by a function of S. Then the elasticity of G respect to S is equal to two parts. The first part, it is the derivative of G with respect to S. Derivative of G with respect to S. If it were a straight relationship, linear relationship between G and S, it is simply the slope taking derivative. Okay, and the second part is the absolute value of S and G at that point. So remember we talked about that before. So if we have a straight line, so G and S has a linear relationship, this slope never change. Taking derivative of G with respect to S is the slope. You can calculate by from one point to the other point, how does the vertical change and how does the horizontal change, the ratio between the two of them. If we had a nonlinear relationship, we have something like that, G respect to S. For one point, for example, this particular combination, then what we do, we take a derivative. And previously we talked about that if we draw a very short straight line that happen to be tangent on this curve, then the slope of this straight line is the value of the marginal value on this point on the curve. So here we use taking derivative on the first part. And the second part, S over G. So the value over here, S over G. Okay. Then the elasticity sign, elasticity coefficient sign also provide us the quality relationship. If their sign is positive, means the percentage change in G and the percentage change in S move to the same direction. There's a positive relationship. If they're negative, it means they move to opposite direction. Then the absolute value, the magnitude, also tells us something other than sign. If we ignore the sign part, take an absolute value, if the elasticity of G over respond to S is positive, means the percentage change on numerator is larger than denominator. So for the same for the certain amount of a percentage change on S, G change by a bigger percentage. So we say it's very responsive, very elastic. G is highly responsive to the change of S. But if it were smaller than 1, means the numerator is smaller than denominator absolute value. That means for the same percentage change on S, G does not change as much. It's not very responsive. Inelastic, we call it inelastic. So elastic, inelastic, not so elastic. Okay. And the very, I believe you come across this in your principles of class, the Most important and first elasticity we learn is own price elasticity of demand. It measures responsiveness of a percentage change in quantity demanded because of the percentage change in price for X for the product. And generally speaking, the sign is negative because a lot of demand, more expensive. People can not many people can afford. Quantity demand decrease, price decrease. People purchase more, and the absolute value tells us how much the quantity change in response to the 1% change of price. The absolute value larger than 1, we say is elastic. 1% increase in price lead to more than 2%, more than 1% of a decrease in quantity demanded. So the absolute value ratio is larger than 1. And if it's smaller than 1, is inelastic. So 1% of increase in price lead to less than 1% of decrease in quantity demanded. If it equal to 1 means 1% increase in price leads to exactly 1% decrease in quantity demanded. It's called unit. 1 means unit. And here I want to introduce the more about the calculation of elasticity coefficient of demand. So if we have a demand function written as this, as price is by itself on the left-hand side, we call this inverse demand relationship. We discussed this in last video. And this is convenient to construct a graphical expression. The vertical intercept on price is 40, and the slope is -1. So rise 40 over run 80 is negative, downward sloping is negative 0.5 or 1/2. But we want to check how quantity change in response to the change of price. So we rewrite this inverse demand function as demand function. Move the quantity to the left-hand side by itself, price to the right, and then multiply 2 throughout. This is our demand function. Now, remember the basic formula for calculating the elasticity of any variable in response to another variable. It is calculated as taking derivative of the response variable with respect to the changing variable, independent variable, taking derivative, then multiply the value of independent variable and over the value of the dependent variable. And here we want to check how quantity demanded change in response to the change of a price. So we have a two-part and focus on the first part, taking derivative of Q with respect to price. We learned this in the taking derivative video. We say 80 doesn't have any price, just ignore that. For negative 2p, you can rewrite it as negative 2p to the power of 1. Then you move the power 1 up front as coefficient. Multiply original negative 2, then original power 1 minus 1. Any variable to the power of 0 is 1. So it is negative 1. Okay. So the slope, if you say the slope here, is negative 1. Q respect to take derivative of Q respect to P is the slope in front of it, negative 2. Or inverse of the inverse demand function. Inverse of negative 0.5 is negative 2. Now, I'll give you an example. Let's pick one point on this demand curve. We say price of 30, price equal to 30, and quantity equals 20. And we can calculate the total revenue. So for each unit you sell, you can collect $30. And how many units you sell? You sell 20. So the product of the two, 600, is the total revenue at this point. Then we'll further calculate elasticity. And here we know that the first part is -2. And multiply the second part. Price is 30. Quantity is 20. And we calculate this one, it is -3. So we know the elasticity coefficient over here is -3. And as the absolute value is larger than 1, means for a certain percentage of a change, increase in price, like 1%, the quantity demanded decrease by 3%. So it's larger than 1, so it's elastic. Quantity is very responsive to the price change. Elastic, -3. Next part, if we have a different point, price equal to price equal to $20 and the quantity is 40. Remember, the slope doesn't change. The derivative doesn't change. It's irrespectful, like it's not relevant to the absolute value of price or quantity. The slope never changes. It's always -2. Multiply current price, quantity over quantity, is -1. At this point, total revenue is 20 multiplied 40, which is 800. -1, absolute value is equal to 1. Therefore, it is of a uni-elastic. Okay. Next part, if we have this point, price of $10 and quantity of 60, the elasticity doesn't change. It is 10 over 60. The elasticity coefficient is -1/3. And corresponding total revenue is 10 multiplied 60 is back to 600 again. And the absolute value of -0.333 is smaller than 1. So quantity is not that responsive to price change. So it's inelastic. -1. Okay. So we can say from here the elasticity change from -3 to 1 to -1/3. So for a straight line, for a straight demand function, the slope doesn't change. It's always -2. However, the ratio between price and quantity decrease, moving from upper left, higher price, lower quantity, to bottom right, lower price, higher quantity. So the ratio moving to this direction decrease. Therefore, the demand, the elasticity varies along a linear demand function. Moving from upper left to bottom right, it becomes more and more inelastic. More and more inelastic. Okay. Now here is a conclusion for the relationship of or relationship between demand function, price, quantity, and the total revenue quantity. So the upper and the bottom graphs share the same horizontal axis quantity. The upper vertical is price, lower vertical is total revenue dollar signs. So if we do the product of price and quantity combination, 40 multiplied 0 is 0. 35 multiplied 10 is 350. We can calculate the corresponding total revenue. And we can say as demand moving from upper left to bottom right. At first, whenever price decrease from 40 to like about 20, price decrease, total revenue increase. Price and the total revenue move to opposite direction whenever demand is elastic. Whenever price, total revenue is plateaued or achieves maximum value, price change, the total revenue doesn't really change whenever demand is of a unit elastic. So coefficient of elasticity is -1 whenever total revenue is plateaued, achieves maximum value of 800. And whenever at the bottom right, demand is inelastic, price goes down, total revenue goes down, or price go up, total revenue go up. They move to the same direction, demand is inelastic. This is called the total revenue test. And this is a text summary of what we described in a graphical expression. Where demand is elastic, price and total revenue move to opposite direction. One increase, one decrease, one decrease, one increase. Whenever demand is inelastic, they move to the same direction. Increase, increase, decrease, decrease. Okay. And whenever it's unit elastic, total revenue is maximized. So for these three variables, knowing two, you're supposed to be able to figure out the other one. So for example, let's say the demand is elastic and the total revenue increase. How does price change? We know price decrease. There are two extreme situations for elasticity. The first one is perfectly inelastic. Perfect inelastic means no matter how price change, price increase, price decrease, the quantity demanded won't respond to it. It's a fixed number. There rarely is any perfect inelastic demand situation, but to give you an intuition, like medicine, medical treatment, like you have, for a certain health condition, the doctor prescribe you a dosage, like let's say 2 pills per day. You will take 2 pills per day. Whenever it's dirt cheap, you don't say, okay, it's very cheap, very affordable, I'll take 4 pills per day. And whenever it's expensive, say, let me skip a couple of days. It's not good. I mean, you can do that, it's not good. So for those type of like medicine or medical treatment, the quantity demand is kind of irrelevant to the price change. That's why some pharmaceutical company increase the price of the product. For example, EpiPen. I discussed that in my principal class. EpiPen increased their price like 300% in short amounts of time, and their profit increase. It's not like consumers don't want to respond to that higher price. They don't like the higher price, but there's no cheaper alternative during the patent protection period. Whenever you need EpiPen, you need EpiPen, no matter what the price is. So it's consumers are relatively inelastic to this type of price change on this type of products. The second extreme situation is called perfectly elastic. Perfectly elastic. So this type of demand, the coefficient elasticity approach negative infinity. And there rarely is any perfectly elastic situation. One example will be like agriculture market, well, more like international trade commodity market, like standardized beans, soybeans, standardized cotton. They're very sensitive to the price change. Price increase a little bit, that will change international trade quantity demanded dramatically. Very responsive to the price change. So it's kind of like, see my example for perfectly elastic demand. There are factors affecting on price elasticity. There are three. The first and second are talking about the same thing, which is if there's alternative. So if price of product increase, how will consumer respond to it, by how much? Essentially depends on if they can find a cheaper alternative. If they don't have much of a perfect substitute or alternative, they cannot be responsive to the price change. Price increase, decrease, if they need to use these products, they use products. The second one is a time duration or purchase horizon. Time duration, if we get more time, it's more likely for consumers to find a cheaper alternative. It's more likely for the producers to develop cheaper alternative. For example, back in 2008, the summer, right before the subprime crisis, the gas price skyrocketed to more than $4. We're talking about 2008. In the immediate short run, consumers can do nothing. If they need to drive, they gotta drive. They need to commute. So there's not much they could do to respond to that price increase. But in the long run, shortly after the electricity cars are widely developed, right? Like we have Nissan Leaf, we have a Chevy Volt, then there's Tesla, BMW i3, i5. So whenever there's longer time, there's alternative developed, and more likely consumers can be responsive to the high price of gasoline if the high price of gasoline persists. Right? So time or purchase horizon provide consumers to find alternatives or substitutes. Next one is expenditure share of consumers' budgets. So we're talking about percentage change, but like 1% change on $1 shake of salt, absolute value is 1 cent, and 1% change of $300,000 of a house will be $3,000. So the absolute value is quite different. Whenever the expenditure of the product account for a larger percentage of your budget, like house or vehicles, consumers are responsive to that price change. And for those products, expenditure accounts for a small percentage of your budget, like say toilet paper, toothpaste, candy, or a shaker of salt. Um, Consumers are not that responsive to the price change because absolute value of price is not much. And here I want to introduce the formula of the relationship between marginal revenue and elasticity. Remember, marginal revenue can be derived from a market demand curve. A marginal revenue measures the extra revenue generated by one more unit of product. Let's say if you are a chocolate factory, if one more box of chocolate is produced, how um, much money, how much extra money can be generated by this one box of chocolate. If you're a t-shirts company, if you produce one more t-shirt, what is extra revenue generated by this one more t-shirt? That's the meaning of marginal revenue. And the relationship between marginal revenue and own price elasticity of demand is as follows. Marginal revenue equals to price multiply a ratio. The numerator is 1 plus elasticity of own price elasticity of demand, which obviously is negative, and denominator is the own price elasticity of demand, which is negative. Now the sign matters. If elasticity coefficient is smaller than -1, let's say smaller than -1, let's say -2, okay, then 1 minus a value that is larger than 1, like a -2, the numerator will be negative. Here, 1 minus 2 is -1. And denominator is always negative. So negative, negative, marginal revenue is positive. Whenever the coefficient, the elasticity, own price elasticity of demand is -1, then 1 minus 1 numerator is 0. So marginal revenue is 0. And whenever coefficient elasticity of demand is smaller than 0 but larger than -1, let's say negative 0.2, okay, then 1 minus a value smaller than 1, it is positive. Here 1 minus 0.2 is 0.8. So numerator positive and denominator is negative. So the whole thing is negative. Marginal revenue smaller than 0. Now here's a graphical expression. We have a price, demand, and the price whenever is 1 unit is offered. This is corresponding marginal revenue. Actually, for a straight line, for a straight demand curve, marginal revenue and the demand curve start from the same point on a vertical intercept, and marginal revenue always cut on horizontal axis half as much as the demand curve cut. So if here were 6 and here's the 3, is it 8? Is it 4? Is it 12? Is it 6? If it were a straight line demand relationship. Okay. So marginal revenue is 0 over here. So this is actually price. Okay, this is wrong. This is the marginal revenue. This is the price. And whenever it's elastic, marginal revenue is above the horizontal axis is positive, whereas unit marginal revenue is equal to 0 cross horizontal axis, whereas inelastic marginal revenue is negative. Now, let's introduce cross-price elasticity. So if we have two products X and Y, we want to check how does the price of Y influence the quantity demanded for X. Okay, so XY, if price of Y change by a percentage, how does the quantity demanded for X change in percentage? Is called cross-price elasticity. If price of product increase result in an increase in the related products, then they are substitutes. For example, if price of a Coca-Cola increase will discourage people from purchasing Coca-Cola, but just push them to purchase cheaper Pepsi. So positive, they're substitutes. If the cross price elasticity is negative, X, Y are complements. For example, price of gasoline increase dramatically. That will discourage people from purchasing fossil fuel cars, and they will switch on to purchasing like an electricity car. So they move to opposite direction. They are complements. Now here's a practice. I'd like you to pause and come back for the answer. It said cross-price elasticity demand between clothing and food is negative 0.18. If price of food is projected to increase 10%, how does that change the demand for clothing? All right. So we use the formula, right? We use a cross-price elasticity formula right here. It tells you that the cross-price elasticity coefficient is negative 0.18, and also tells you the price change. Price increase for food by 10%. So denominator is a positive 10%. And now I ask you, how does the quantity change in percentage? Okay, so according to the mathematical rule, we check the product of the coefficient of elasticity, cross-price elasticity, and the 10%, and figure out. Okay, it is negative 1.8. Actually, here you are encouraged to put a percentage sign over here. Okay, 10%. What we do about percent, you just copy it. Only worry about numeric part. 10 multiplied negative 0.18 is negative 1.8. So the interpretation is demand for clothing is expected to decline by 1.8% whenever price of food increases by 10%. Why do we need to learn the cross-price elasticity? It is very handy whenever a firm sells multiple products. For example, you go to McDonald's, it doesn't only sell hamburger, sandwich, also sell drinks and dessert, ice cream, coffee, and so on and so forth. It sell multiple products. So here we want to know, for example, if we increase the price of soda by 10 cents, by 10%, for example, how does that influence the quantity demanded for soda, and therefore the revenue for soda, and also influence the sale of a sandwich, therefore the revenue for sandwich. We want to check on that. And here is a formula. If this restaurant or this firm sell, for example, two goods, if one product price change, let's say X change, percentage in change in X, how does that influence the revenue of the firm? It has two components. The first one is own price. It is the revenue of X multiplied 1 plus elasticity of coefficient elasticity of own price elasticity. So price change, how does quantity of X change? Plus, how does that influence the related products? Like soda price increase, how does it change the revenue for sandwich? It is revenue of Y multiplied the cross price elasticity of how quantity demand change of Y respect to the change of price of X. And here's an example. Use this formula and solve this problem. Pause and come back for the answer. All right, so this question say this restaurant sell two products, hamburger and soda, okay, X and Y. And say own price elasticity of burger is negative 1.5. And the cross price elasticity demand of a soda in response to the hamburger is negative 4. Soda Y in response to price change on X, hamburger is negative 4. What will happen to total revenue if it reduce the price of a hamburger by 1%? Reduce means decrease, so negative 1% of price change on hamburger. Okay. So according to our formula, we check on the hamburger revenue, 4,000 multiplies own price 1 plus own price elasticity, 1 minus 1.5 plus revenue of soda 2,000 multiply cross price elasticity negative 4. The whole thing, the big bracket, after summation, the big bracket multiply negative 1%. And say total revenue increase by $100. So lower the price of hamburger by 1% will increase total revenue by $100. Did you figure out? So here 1 minus 0.5, 1.5 is negative 0.5. So 400 multiply negative 0.5. Negative 1.5. Negative 0.5 is negative 1 over 2. Right? Negative 1 half. So it is negative 2,000. Plus, there's a negative sign. So it's negative 2 multiplied 4, 8,000. So negative 2, negative 8, so negative 10,000. Negative 10,000 multiplied negative 1%, $100. 1% is 0.01. Okay. So negative is positive. 10,000 multiplied 0.01 is 100. Next formula, elasticity is income elasticity. It measures responsiveness of percentage change in demand for product X due to a percentage change in income. Okay, income. If it's positive, X is normal good. If it's negative, it's inferior good. Then here's a practice. Pause and come back for the answer. So here we use a formula, right? We know the income elasticity is 1.8, and the numerator is the variable of interest, which percentage change in quantity demanded for transportation. Denominator is percentage change in price. Here I like to put the percentage sign again. Then the product, 1.8 multiply negative 15%. Okay, you just copy percent sign over there. Only worry about 1.8 multiply negative 15. So I got 27%. Now the question is the transportation normal or inferior? And it said the coefficient is 1.8 is positive, right? So positive means demand and income move to the same direction. One decrease, the other decrease. Transportation is normal goods. There is other elasticity like on advertisement. Elasticity is good X is the ratio of the percentage change in consumption of X to the percentage change in advertisement spent on X. So if I increase the advertisement by $10,000, how will that influence the demand of X? Promote awareness of the brand if it's worth it. Then cross-advertising elasticity between good X and Y measure how the percentage change in the consumption of X that result from 1% change in advertisement towards Y. So if I promote the Big Mac of McDonald's, how does that influence the demand for soda in McDonald's? Given a linear demand function we learned before, the own price elasticity we learned, it is linear. So the first part is taking derivative of a quantity with respect to the variable interest. It is simply the coefficient, the slope. Multiply corresponding price and corresponding quantity. And cross price elasticity of y is the coefficient in front of it, alpha y multiply corresponding price of y and corresponding quantity of x. And income is the coefficient multiply income over quantity demanded for product x. So those are the formula, very handy whenever you have a linear demand function. Now here's an example. If we have some shoes, the demand function is a linear format like the following. Suppose X sells at $25 a pair, 25. Good Y sells at 35. And company utilizes 50 units of advertisement. And average consumer income is 20,000. Calculate the own price, cross price, income elasticity of demand for X. All right, so the first step is we know the price. We don't know how many units purchased by consumers. What we do first is figure out the quantity by plugging those numbers in. Okay, price of X 25, price of Y 35, income 20,000, and units of advertisement 50. We calculate the quantity demanded for X is 65. Okay, 65. Then the own price elasticity is the coefficient in front of it, -3, multiply price 25 over 65, we just calculate quantity, and this is a coefficient. Then cross price elasticity is the coefficient in front of a price of Y, multiply price of Y 35 over quantity of X 65. This is the cross price elasticity. The last income elasticity, we say the coefficient in front of it, multiply the income 20,000 over the quantity 65 is negative 3.08. Now I want to introduce a new demand function, which is nonlinear, and it is very handy. It's called a log linear or log demand function. What's the meaning of log? So the left-hand side quantity demanded is in its natural log format. So we take natural log of quantity demanded for product X. And the variables on the right-hand side is also in its log format. We take the natural log of price of X, natural log of price of Y, natural log of income, and other variables. So this is log, linear, and linear in summation format as opposed to the square or multiplication. So it's called a log linear demand function or log demand function. This is very handy because you take a derivative, it give you the percentage change. It is the coefficient in front of it. Okay, so if you have a format of both quantity and the price in natural log format, ask you what is elasticity, it is simply the coefficient in front of it. Okay. And the cross price elasticity is coefficient in front of Y, price of Y, natural log of price of Y, beta Y. And what is the income elasticity? It is a coefficient in front of natural log of income. Now, here's an example. So, analysts for a major apparel company estimates that the demand for its raincoats is given by natural log of quantity demanded for raincoat plus 10 minus 1.2 natural log of price of a raincoat plus 3 multiply natural log of daily amount of rainfall minus 2 multiply natural log of the level of advertisement on good Y. So some other related goods other than raincoat, maybe umbrella or something like that. What would be the impact on demand? of a 10% increase in the daily amount of rainfall. This negative sign, so it could be some like rain boots. Okay, rain boots. Ask the 10% increase in daily amount of rainfall R over here. Okay, so both quantity and rainfall in natural log, the elasticity of a quantity demand for raincoat with respect to rainfall is the coefficient in front of it, which is R, beta R 3. So the coefficient is 3, and ask you the effect of a 10% increase in daily amount of rainfall, denominator 10% increase on quantity demanded for raincoat. Then we do a product, 3 multiplied 10% as a 30% increase in the demand for raincoat. That's all I have for today's video. Thank you for watching. I will see you in the next one.